Hey everyone, in this lesson we're going to do two-state replication and cover risk-neutral probability. Let's start with what is replication of a derivative. So basically we're combining a bunch of assets and producing something that is equivalent to a derivative. In this course we're going to use stocks and bonds just to simplify the idea. Now why would we want to use replication? The idea behind it is we want to determine the price of derivatives. So basically what we're doing is we're getting a combination of assets that we know the price of, and then because we're making something that's equivalent to a derivative, using our assumption of no arbitrage and the law of one price, we are then able to determine the price of the derivative. So what is the two-state model? Before we said we're using bonds and stocks, so bonds will be our risk-free asset and stock will be our risky asset. Basically what this means is the return for the bond is the same no matter what, versus the stock, the return can fluctuate. In the two-state model, what it means is the stock can fluctuate to two different potential outcomes, right? So at time zero, we have the stock price and we have the bond price. Yep. And at time capital T, we have two different states. Again, the bond will always be worth the same amount, and we can see it is in both states. However, the stock price will fluctuate. So in state one, it has a higher return of, and we'll denote that using U, and in state two has a lower return, so we denote that using D. So here's just a property of the stocks and bonds. So the return of the lower stock return has to be less than the return of the bonds, which is less than the return of the higher stock return. Now, why is this the case? It's because of arbitrage. Again, if both the returns for the stock is lower than the bonds, what we could easily do is we could easily short the stock and then buy bonds, creating an arbitrage. Again, the flip side happens as well. If both returns for the stock are higher than the return of bonds, we can leverage the bonds to buy the stock, creating another arbitrage. So, how do we actually replicate the derivative? What we do is we replicate the derivative payoffs. So as we can see, we're using the payoffs in state 1 and the payoffs in state 2. Again, we can see we're looking at some amount of stock plus some amount of bond is equal to the payout of the derivative. And in the first line we have it for state 1 with the lowest stock return, and for the second line we have state 2 for the highest stock return. As you can see, the only differences between 1 and 2 is instead of the lower return in state 1, D, we have the higher stock return of U in state 2. Again, what we do is we just do simultaneous equations. You can plug this in online or work it out by hand. Either way, you'll come to the conclusion below of these two equations. I won't go through them, but yeah, these are the equations you'll need to use to calculate the amount in a two-state replication. Something else we need to use is a risk-neutral measure. So in modern portfolio theory, it states that the current value of an asset should be worth the present value of the expected future returns of the asset. Again, this is quite simple. It's saying that the future cash flows, just when you discount them, is sort of the current value of the asset now. However, there is a bit of a caveat to this one. Investors are often risk adverse. So basically what we do is we use risk neutral measures or probabilities that have risk in it. So they no longer show exact probabilities, but instead they already have the risk in it. So let's compare physical and risk neutral probabilities. So physical probabilities are the exact ones. So these are the ones we're used to, and it's how likely an event is to occur. So sort of like a coin flip. So a stock has a 50% chance of being $20 and a 50% chance of being $10 tomorrow. Its present value, you would think it would be $15. However, it's not, because it does not account for the risk of it being $10, decreasing to $10, and thus it'll be less. However, with the risk neutral probability, we embed the risk within the probability. So, in reality, what we do is we reduce the probability of the good outcomes and we increase the probabilities of the bad outcomes. So again, if we have risk neutral probability and the stock is risk neutral probability 50% chance to go to $20 and 50% chance to go to $10, in this case we actually can multiply them together and discount back to get the $15 given no interest rates. But basically, in reality, although the risk neutral probabilities will be 50% each, it's more likely that the good outcomes, so the chance it'll be 20%, might actually be 55%, and the chance of it decreasing to 10% might only be 45%, just to account for the risk. So, how do we price using risk neutral probability? So how do we figure it out? And we'll be using Q to denote risk neutral probability. So basically, using intuition, we can find out the stock and the derivative values at time 0 using the risk neutral probability. So with the stock, basically I'll explain the formula and it'll become quite intuitive. So in the numerator, we have the risk neutral probability of it moving up multiplied by the price of it moving up plus the probability of it moving down times the price of it moving down. And thus, when we discount it back using the risk-free rate of return, we get the price of the stock. Similarly, if we do the same thing for a derivative, if we get the probability it moves up and we use the payoff of the derivative, when it moves up, plus the probability it moves down, plus the payoff of the derivative when it moves down, and we discount it back using the risk-free rate of return, we get the derivative price. And using simultaneous equations, I won't go through it, it is a bit tedious, we get the following equation below, which becomes one way we can calculate the risk neutral probability. So now we've touched on two-state replication as well as the risk neutral probability. So now we should have some idea of what these two are. Thanks for watching.